All right. So here we are. Now the rest of these, a lot of these questions are you can take straight from um, the video on stealing a base. So if they're multiple choice, it's in the video. Okay. So now let's get all the way down here to this one, to 16 and 17. I think that's where we are because all the rest of them you pretty straightforward. Okay. So let's take a look at something here. I thought the 15 mile per hour for a base runner was kind of slow. I mean, it's a hell of a lot faster than I could run, but I thought that was slow. But still, that equates to about 6.7 meters per second. Or if we look at our feet per second that we were doing, it comes out to 22. Oh, it comes out to 22 feet per second. Now, we're not going to put Usain Bolt's average speed was 10.4 meters per second when he set the world record. So I just looked up the NCAA men's 100-meter dash record this year, which was 2.82 seconds. Calculate that speed in miles per hour. All right. So how would we go backwards with this thing? Okay. So we need to get miles per hour. Now, so this is problem 16. Okay. So we know that he went 100 meters in 10.8 seconds. So when you get that number, that'll give you your meters per second. And then I think we have our conversion factor of 0.447, but that's taking miles per hour to meters per second. This time, where we would multiply, if we multiply 100 meters divided by 10.8 seconds times 0.447, that won't do us any good. We don't want to do that. Okay? Because the 0.447 is for going from miles per hour to meters per second. So if we want to get miles per hour by itself over here, what do? This is mathematically how this works. So take whatever you get here and divide by that 0.447 and see what happens. And so on 17, we take a look at problem 17. It says, let's allow for the baseball helmet. So calculate that speed in meters per second, in miles per hour is what you did. And so let's allow for the baseball helmet, clothes, baseball spikes. It says Jackson. Let's put Christian Coleman, that's the young man's name who broke the NCAA record in the 100. Oh, I wonder if you put 19 and 16 if it would work. Probably. I think so. Instead of taking a lead off and getting the jump, Coleman gets it like what this is being discussed on online forums with baseball geeks. Okay, instead of having these speedsters take leadoffs, get a track star. Because even a track star that's like past competing for the Olympics is still pretty darn fast. Okay, get a track star and just for your base stealing guy in the majors and just having push off first base. He doesn't even take a lead. And averaging 19 miles per hour, going to run the 90 feet to second base, how fast is he going to get there? Well, that's a lot of fun. And you saw that the very very fastest that they could get off the throw to catch the guy stealing was 3.25 seconds. Look at this. This is an interesting calculation. So how does this work? So averaging 19 miles per hour so again, we've got X, so we got 90 feet. 90 feet is equal to that 19 miles per hour in feet per second. So you've got to have 19 miles per hour. Got to convert that to feet per second. And we've already done that. We have our little conversion thing. Okay. Times the time. So you're going to get a number here. All right. And now you need to solve for this guy. You got to do that, right? So in other words, the example. If you have 6 equals 3x, How do you solve for x? 6 divided by 3 equals 2. So x equals 2. All right? That's the example. How are you going to solve that? Okay? Well, this was a mini lesson, so have fun with it.